Hey, it's Jacob. Welcome to this new video. Today I'm going to talk about how to make your Python scripts more reliable, and specifically how to work with erroneous data. By the end of this video, you'll have a framework for thinking differently about reliability. I'll tell you exactly how I did it myself. I'll give you a real-world example of making your script more reliable, and I'll tell you how you can get away with improving reliability when you don't have a lot of time or test cases. Make sure you stay till the end of the video if you don't want to miss out on a step-by-step action plan to apply it yourself. But first, maybe you think that certain tasks you can't have a script for because you can't afford to make mistakes while doing those tasks. And you might feel stuck because you don't know what to do about it. You have to endure those tasks. Or you might think that Python scripts might work for other people, but it can't work for you because there is nothing systematic at your work. There is nothing recurring. It might make you feel like there is no clear pathway for people like you. Or finally, maybe you just don't know how. You think that it's possible that there is a way to create Python scripts that will do some of the tasks for you, but you don't know how to make them reliable. And maybe you feel like you could figure it out, but you don't have the time to really learn about it. And here is the way that most people are going to go about making scripts more reliable. It's going to take a lot of time and test cases to make the script very reliable. And the rationale behind it is you use the script for a period of time, and over that period of time you will see all the different mistakes that this script is making. And because of that feedback loop, you will make the script better and better and more reliable. And so effectively in this case, time and test cases are working the same way in the sense that they are making the script more reliable. The more time you have, the higher the chances of finding errors in your script. The more test cases you have, the more chances you have to find errors in your script. And that's how most people go about it. And the question is, what if you don't have or can't afford time or test cases? What if you need to have a working solution that is reliable right now? What if you have too many test cases? What if there is too many errors that can happen? What if there is an infinite amount of test cases and you can't fix them all? And so what we really need is a solution that works even if we don't have time or test cases. And that's exactly what happened to me. I had to come up with something, and here is what happened. I had to deal with typos, and typos are exactly the kind of problems that generate an infinite amount of test cases. And let me explain why. I had to look for information in a nested structure of folders. What I mean by a nested structure of folder is a folder inside a folder inside a folder. That's usually what tends to happen when we work on a project, because we create different folders for different categories, and then we have subcategories, and then in those subcategories we create categories, and so on and so forth. That's usually what you have when you work on any project. You have one folder and you have tons of folders in that folder, but they are not all at the same level. And most companies have certain rules to name those folders based on where they are in the structure. So then you might think, well, that's really easy then. All you need to do is implement those rules so that you can navigate in that structure using a Python script. And that's where typos come in. How do you deal with folders that are following the rules but that have typos in it? Idea number one, you implement the rules and have an expected name for a specific folder. Then you compare each letter from that expected name to every letter for every folder. And if one folder contains all those letters, that means it's the correct folder. And there are a few problems with that approach. One, what if the letter is not something that was added to the word, but something that was subtracted to the word? Then that approach doesn't work, because we're looking for a folder that contains every letter from the expected name. Also, what if there are more than one folder that contains all the letters from the expected name? There are tons of other problems that I'm not going to get into, but the point is, it's just a bad idea. Idea number two. Look at the number of letters in common with the expected name. But again, the problem is, what if there is the same number of letters in common with different folders? And maybe looking at the order of the letters might solve that problem. But there are other problems too. What if there are two folders that are very similar and there is a typo in one of them? You take the risk of choosing the wrong one using that algorithm. So that brings us to idea number 3. And idea number 3 consists of taking a step back, because that's actually not how we do it in the real world. For us, it's very obvious to see which folder is the correct one and which one is not the correct one, even if there is a typo in it. The question is, what makes it easy for us to do it reliably? And the answer is it's because we do it differently. We look at the words and see how different they are. We quantify how different they are. And this is where the idea of having a distance between two words comes in. So at this point, I did some research and the distance actually already exists. It's called the Levenshtein Distance. It basically tells us how many single character edits we need to get from one word to the one we compare, the expected one. Now, why does that change the game? Because now, instead of having a binary bit, 2 words are the same or 2 words are not the same, we have an integer telling us how different 2 words are. Well, that pretty much solves the typo problem in a much more robust way, because now it becomes a distance threshold under which the words are the same, but there is a typo in one of them. Obviously, it's not perfect, because sometimes words are very similar and still different, so we might have to combine the Levenshtein distance with another approach. But that's one way to make a script much more reliable without tons of time or test cases. And of course, in case you're wondering, the Levenshtein distance algorithm can just be copied and pasted from the internet. It's really easy to find. So the point of this video is that if I did it, you can do it too. Of course, it's not going to be that exact example, but you can find ways to make your script reliable. And I'm going to give you a step-by-step action plan to apply it to your life. The first step is identify. If you see the same type of mistakes occurring and you keep improving the script but you keep seeing mistakes, that doesn't mean you should tell yourself this is the last time that happens. It means you should take a step back and ask yourself, how would you do it? If you were to do it by hand, how would you do it? How would you describe your decision-making process with words? If you can reliably do it, there is no reason why a script wouldn't be able to reliably do it. So if it's obvious to you, ask yourself, why is it obvious to you? What specifically makes it obvious to you? And step 3 is research. Literally type the words that you came up with during your description of your decision-making process and add the following words to it. Algorithm, Python, function. Add one of those 3 keywords and you might find algorithms that already exist. If the algorithm already exists, this is the only way to get away with not using a lot of time or a lot of test cases to have a reliable way of doing one thing. And the truth is, you're not getting away with it. You're simply leveraging somebody else's time or somebody else's test cases to make whatever you want to do more reliable. Now, if you are just getting started with Python scripting, what you need to take away from this video is that we're in 2022 now, and there are things we can do now that we couldn't 20 years ago. If you think that whatever you're doing at your work can be done reliably by a Python script, you might want to question that assumption. And if you do want to suspend disbelief and try it for yourself, but you don't know where to get started, I created a free online course to help you specifically with doing that. You can click on the link in the description to get it. Have a great day and see you in the next video.